All right. So, excuse me. Sorry. Today we're looking at hypothesis testing, and our goal is that you can carry out a chi-squared test, a chi-squared goodness of fit test, and a two-sample t-test using a TI-inspired calculators. So here's our first question. As part of a study into health styles, Yin visited Surrey Hills University. Yin recorded a person's position in the university and how frequently they ate salad. Results are shown here in the table. So Yin conducted a chi-squared test for independence at a 5% significance level. What will the null hypothesis be? Have a go at writing this one down. No. Start with this phrase. Or the choice of. And then you need to use the word independent of. And then describe what this is. Okay, so let's have a look at an answer here for this one. So in A, we are going to do so we're looking at salad meals per week. So something like number of salad. Oh, sorry. Let me start again. This is the null hypothesis, so we should label it as such. And then we go for the number of salad meals per week. And then the key phrase is independent of. That's our key phrase. And then we need to describe what this is, and that would be position in the university. Position in the university. Okay, B. Right, use your calculators now to calculate the p-value for this test. Put your hands up if you need help. Already? You're going to try. Okay. Okay, so we should get for our p-value, p is equal to 0.0201. Make sure you give your answer to 3 significant figures. Because of that 0 after the 2, many of you were tempted to really shorten this one to 1 significant figure, and that's really going to cost you. So then we have to state our conclusion, and we have a very strict format for this conclusion. So we have to start with a comparison of the p-value to the significance level. So we say that 0.0201 is less than 0.05. This implies that the p-value is less than the significance level. There are two outcomes of this. There are two possible outcomes. We are either going to reject or fail to reject. So when we compare, we are either going to reject or fail to reject. Which one will we do this time? Reject. Why? So we say there is sufficient evidence to reject the null hypothesis. The salads per week is probably not independent of position in the university. Okay, let's have a go now at this one. So, Ms. Calhoun measures the heights of students in her math class. She is interested to see if the mean height of the male students, mu1, is the same as the mean height, or the population mean height, of the female students, mu2. The information is recorded in the table. At a 10% significance level, a t-test was used to compare the two groups. The data is assumed to be normally distributed, and the standard deviations are equal in both groups. State the null hypothesis. So have a go at stating the null and alternate hypotheses. All right. So it's actually quite easy on this one. So for A, the null hypothesis is going to be that mu1 is equal to mu2. And the alternate hypothesis, H1, is that they're not equal. So we just do a little bit of revision here on this one. So we're working with mu. This is the population mean. Compared to x bar, which is the sample mean. What's the difference between those two? Vivian. No, it relates to basically the data that's been collected. So the teacher is looking at the heights of students in her class. So that, because this is mu1, that means that she has 7 boys in the class and 8 girls. So that's the entire population of the class. It's not a selection or a sample of the class. So the difference between these is we use mu when it's the entire population, and we use x bar when it's a sample of the population. All right, have a go now at carrying out the test and finding the p-value. All right, let me resume. So When you're working with your calculator, we always want pooled yes for this test. Don't forget it's the 2-sample t-test. That we're performing, and we enter this into list, not a matrix. We type that into a list. So then it will give us a p-value equal to, let me have a look at my calculator. What did I get? 0.296. 0.296. So now we have 0.296 is greater than 0.10. So p-value is greater than the significance level. So do we reject or fail to reject? So there is sufficient evidence to fail to reject the null hypothesis. Sorry? Yeah.
Yeah, we both rejected the null hypothesis.
You rejected the null hypothesis.
Right. We shouldn't.
Yeah, it's the same thing. Yeah.
We shouldn't be rejecting. We should fail to reject.
Oh, yeah.
So the important part of it is the fail to reject. This is the important part. Fail to reject the null hypothesis. You either reject or you fail to reject. Failing to reject means we think it could possibly be true. This implies, what does that mean?
One does not equal the need to.
Yeah, which is, what is her hypothesis she's working off of? Can we have it in more in words?
The mean height of male students equals the mean height of female students.
Yeah. So the population mean of males and females is the same. Okay, last one. A dice manufacturer claims that for a novelty... Sorry, I just make sure I get this on the video. So these are our results there for that question. Okay, our last one. A dice manufacturer claims that for a novelty die, he produces the probability of scoring 1 to 5 are all equal, and the probability of scoring 6 is 2 times the probability of any others. To test it, the manufacturer rolled the dice 350 times, and the numbers scored on the die are shown in the table. We are going to do a chi-squared goodness of fit test at a 5% significance level. So first off, find the probability of rolling a 6 with the novelty die. Are we ready? Okay. So look at the points we've got over here. These questions are hard. They're not quick and easy questions. So you can tell by the number of points that it's going to take a little bit more work. So he tells us that the numbers 1 to 5 are all equal, and the probability of rolling a 6 is 2 times the probability of the others. So for A, we can do a discrete probability table. So we've got X, and we've got the probability that X equals X. You put up a little table. So you have the numbers 1, 2, 3, 4, 5, and 6 on the die. So what is the probability of rolling a 1? We'll call that P. We don't know. What will be the probability of rolling a 2? P. And a 3? And a 4? A 5? A 6? Good. 2P. What's the total probability? What's the total probability? 1. So 7P has to equal 1. What's the value of P?
-6.
1 over 7. What's the probability that X equals 6? 2 over 7. This is what the question wants. Find the probability of scoring a 6 when rolling the die. 2 over 7. B. Find the probability of scoring more than 2 6s when you roll it 5 times. How do we do this? Why? Why is it a binomial? What in the question tells us this is a binomial distribution?
There are a number of rules.
You've got 2 things. You've got set number of trials. How many trials do we have?
350.
Nope.
And there's a lower bound.
No?
5.
5. Read B. Find the probability of scoring more than 2 6s when the die is rolled 5 times. Set number of trials? 5. Probability of success for each trial? What is the probability of success for each trial? 2 over 7. So when we see that in a question, we see binomial distribution. So with a binomial distribution, you can always describe it using X is the number of ... Now what will X be the number of?
6 is rolled.
6s rolled. X will be the number of 6s rolled. So we say that X is distributed binomially, and then we need the 2 parameters, which would be 5 and 2 over 7. This is our probability distribution. That's how we define the probability distribution. We want the probability that this X is greater. So let me just read the question again. We want score more than 2 6s. So more than 2. With a binomial distribution, we have to change that across to say that this is x is more or equal to 3. We can't do more than, we have to do more than or equal to. It's a discrete probability distribution. You can't roll 2.5 times with this. It's a discrete probability distribution. X is the number of 6s rolled. X can be 0, 1, 2, 3, 4, or 5. It can't be any numbers in between. It's not a continuous like the normal distribution. So then we use our calculator for that. So have a go now at using your calculator and coming up with your value. Let me come around and help on that one. All right. So what's the next question? Find the expected frequency of each number of if the claim is true. Okay. So we need to find the expected frequency for each one. The expectation. I called that one x as well, didn't I? Oops. The expectation that x equals 1 is equal to 1 over 7 times 350. So the expectation is the probability multiplied by the number of trials. So he did 350 rolls. If his claim is true, then 350 times p should give us this number, and that is going to be 50. So the expectation of 1 to 5 is going to be 50, and obviously the expectation of 6 is going to be 2 over 7 times 350, which is 100. So onto this table, it adds a little bit for us, doesn't it? So these are our expected values of x, and it's going to be 50, 50, 50, 50, 50, 100. So using these two values, type them into your lists in your calculator, and we need to find the conclusion to the test, justifying the claim or not. So find the p-value. All right, so we have to determine the conclusion to the test. So for D, in order to do the test, we need the degrees of freedom. So let's put that on our page, because it might get us a point. So the degrees of freedom is rows minus 1, which equals 6 minus 1, which equals 5. And typing into the calculator, we get our p-value. So we enter this into the calculator. This is our observed, I can't spell observed today. Observed values. And these are our expected values. Expected. So we put these two columns into our lists and then go into the chi-squared goodness of fit test, set our degrees of freedom to 5, and we should get a p-value of 0.0984. So then we need to compare the two. 0.0984 is greater than 0.05. I think it was 5% significance level, wasn't it? Yeah, we just check. 5% significance level. This is the p-value is greater than the significance level. If the p is low, reject the whole. So the p is not low. There is sufficient evidence What is the opposite of rejecting the whole? Failing to reject. There is sufficient evidence to fail to reject H0. So what does this say about the claim? What was the claim?
There is scoring 1 to 5 are all equal, and the probability of 6 is twice the probability.
Yeah.
Which validates the manufacturer's claims.
Yeah. The manufacturer's claim appears, always the vague language of stats, to be true. The probability of a 6 is equal to twice the probability of 1 to 5. All right. That is it for our intro today. If you go to the Google Classroom, I've shared with you some questions to do.